So a major assumption I need to talk about is number 18 on the homework. It asks you to rank the electronegativity of potassium, chlorine, and neon. You should recognize that the noble gases are common exceptions to everything. The noble gases do not want any additional electrons. So even though the electronegativity as you go to the right increases, you should almost assume it's zero for the noble gases. They should be an exception. Lucas, I almost want to count all of them wrong. Remember, capitalization versus, so capitalization for like sodium, you put lowercase n a.
Oh, I didn't capitalize SI or magnesium.
Yes, I almost wanted to count that wrong. And some people put a L that did not extend all the way up. They put a little half L, which makes it look like either a I without the period above it, or the number subscript 1. Again, these are not supposed to be letters. They're supposed to be symbols. So no writing cursive or doing anything funny with it. They should look, besides I, because when you print I, it looks like a straight line. They should have bars above them and below them. On the back, common exceptions I saw was people not looking. So, fifth from the bottom, members of the transition metals. It's not Ti for titanium, it's TL for thallium. So 81 versus 22 on the periodic table. You should make sure to look at carefully. Mercury was the transition metal. What other ones did y'all miss? For the most part, y'all did good on the homework. So remember that you need to read the problem carefully. It's either going to say put it smallest to largest or largest to smallest. So you're going to have to think backwards sometimes. Y'all have any questions on the homework? Y'all should be able to look at which ones you got wrong and correct it. You have y'all's periodic table? Y'all need a new one? So, during this Kahoot, take your time. Don't try to go for first place. I will say this about the Kahoot. The Kahoot will be easier than the test. So keep that in mind. Yeah, it's the same as your calculator, but don't worry about it. I found an existing Kahoot and tried to modify it and add some other things to it. I tried playing it, and I think I corrected all the errors. There might be an error that pops up. Hopefully not.
No, the elements. Oh. I was gonna say. I'm probably gonna.
All right. So read the question carefully. This is basically a surface practice. What is the trend of the atomic radius from left to right? So it decreases as you move from left to right. Atoms get smaller. The smallest atom is, I believe, helium. What is the trend for electronegativity as you go from bottom to top? So as you go from down upward, as you go upward, it increases. Remember, fluorine is the most electronegative. What is the trend for ionization energy as you go from left to right? So it increases, meaning it's harder to remove an electron as you go left to right. It takes more energy to strip an electron from a noble gas or from fluorine. Well, noble gas too. Noble gas has high ionization energy because they don't ionize. Which subatomic particle plays the greatest role in determining an atom's chemical properties? Which one plays the greatest role in determining its properties? One clear. Good. This was a proton you might think is the correct answer. The number of protons determines what atom it is. The protons determine the structure of the electrons. So the proton and nucleus gives it the identity of the atom, but after the protons has made the atom, it's the electrons that actually contribute to the properties. It describes how they will react. It's all based on the electrons. So the protons determine how the electrons will move around, but it's the electrons that actually do the chemistry. So that one's a very tricky question. You have to really think about it. Again, on a test, you choose the best answer, not the correct answer. Half the distance between the nuclei of two like atoms is called the atomic radius. How does atomic size change as you move down a group on the periodic table? It increases because you're adding new energy levels. Which of the following atoms has the lowest electronegativity? Oxygen, lithium, and neon. Lowest electronegativity. So remember, we define technically that electronegativity is defined as the ability of an atom to pull in the electrons in a bond. So we technically define electronegativity that when two atoms bond together, which one pulls more strongly on the electrons? However, neon doesn't bond with anything, so it never has any pull on any other electrons. It is perfectly fine by itself. Having no pull means that it has the lowest electronegativity. You can almost think of all the noble gases as having zero electronegativity. So a trick question. Recall that the noble gases are going to be exceptions. Especially when it comes to electronegativity. That's the major exception you should pay attention to. So noble gases have the lowest because they break the trend. Which of the following atoms would have the highest ionization energy? Oxygen, fluorine, and chlorine. They make up the top three, top right atoms, ignoring noble gases. You should have their position basically memorized without looking at a periodic table. Oxygen, fluorine, and chlorine are top right. Since chlorine is mentioned in neither of the other two, you should at least know that this is at the top right of the periodic table and thus has the highest ionization energy. It takes a lot of energy to strip electrons from chlorine. Which element has the smallest atomic radius? So again, fluorine is at the top right. As you go to the right, you get smaller, and as you go up, you get smaller. You should have atoms like hydrogen, helium, fluorine, oxygen, chlorine, lithium, sodium, potassium, magnesium, calcium, and all memorized where they're at on the periodic table without looking. I would say the halogen group in general, diatomic atoms in general, and iron and copper are a few ones that are going to be used an extremely large amount in class. Atoms with small radii tend to have higher ionization energies. So having a small radii means that you're going to the right and you're going up. So as you go up and to the right, does ionization energy increase? It does. So that's true. Which type of ion typically has a larger atomic radius than a neutral atom? Anion or a cation? Two seconds. So remember, you can alphabetize it. A is less than C. So A should be your negative, C should be your positive, because that's how it is on the number line. And we know that negative ions produce bigger atoms. So as a neutral atom becomes an ion, if it's negative, it gets bigger. Which of the following would have the smallest atomic radius? Five seconds. So, we know that as we become a positive ion, we get significantly smaller. And we know that as the ones above or at the top are some of the smallest atoms. So, we know we need to be a positive, and we need to be up high. And remember, as you go to the right, your size decreases when you're an ion. So looking at this, we see calcium and potassium ions. They're up top. So they're above all the others. So those are going to be the smallest two. The negative one you can roll out immediately. The neutral one is right next to calcium. Since it's neutral, you can roll it out because because the other two, when they become ions, significantly get smaller. And so you should immediately rule out all but calcium and potassium. To know the difference between the two, calcium is to the right, so as you go to the right, your size gets smaller. Which of the following atoms would most likely lose an electron? Two seconds. So, if I had to very quickly guess, I would have guessed lithium because I don't know RB very well. So you should know that this is the most likely to lose an electron would be the ones that have one valence electron. But if you look, rubidium and lithium are both one valence electron atoms. And lithium is up high, so the outer shell is very close to the nucleus. So it's going to pull more strongly on that electron. Rubidium is at the bottom, so it's not going to pull as strongly. Because of that, rubidium is going to be more reactive. If you remember the video we watched yesterday, when he put rubidium in, it immediately burst into an explosion. When he put cesium in, it even broke the glass. It's more reactive because it quickly gets rid of the electron. As you move from left to right across the periodic table, electronegativity does what? It increases as you go left to right. Remember, on the test, you're only going to have the blank periodic table. So you should have most of this all memorized and not be looking at notes. The energy required to remove an electron from a gaseous atom is called what? Ionization energy. Which group of elements has the lowest ionization energies? Very good. Alkali metals on the left. Which of the following halogens has the greatest affinity for electrons? Chlorine. So halogen group goes fluorine, chlorine, bromine, iodine. So I remember, I usually don't think about acetine too much, but I know it's the last one in it. How does the atomic radius of non-metallic neutral atoms compare with their atoms, or their ions, I mean? So non-metallic neutral atoms, how they compare to their ions in atomic radius. So non-metallic means we're looking at the right side. Those are going to be the ones that become anions or negative ions. So they're going to gain electrons. The non-metallic atoms are going to want to gain electrons and get bigger. Which of the following is a metal? Potassium. Which of the following has the largest ionization energy? Which has the largest atomic mass? Very good. Which is a halogen? Largest atomic radius. So they're all in the same row. So as you go to the left, they get bigger. Largest atomic number. Which one is a noble gas? Xenon is one of the noble gases. Which one has 3 energy levels with electrons? Which one is an alkali metal? Which atom has 4 valence electrons? So the carbon group has all 4 valence electrons. Which one has the electron configuration ending in S2P1? That's the boron group. Boron groups all have P1 because they're the first column in the P block. The carbon group is all P2. The nitrogen group is P3. Oxygen group is P4. Noble gases would be a P6. But it depends for the noble gases. No, it doesn't. If it has a P6 at the very end of it, that guarantees you it's a noble gas. Unless it had a D, if it had a partial D or something. What is a period? The rows. Which of the following are metals? It's potassium. I added krypton because it began with a K, but the symbol is Kr. Which element is in group 16, period 2? Period 3. Period 3. My bad. I misread it. Sorry. That was close. Which element in group 15 has the greatest tendency to gain electrons? So nitrogen is smaller than all the other ones, it's up higher. So the outer energy level is closer to the nucleus. So if an electron gets in that spot, it's going to pull on it really greater. While the other ones, their pull is much smaller. Think about the solar system. If you put a planet in Earth's radius, the sun is going to pull on it more strongly than a planet that's zooming by Pluto. If some rogue planet going throughout the universe were to go and go through our solar system, if it goes through Mercury's orbit, it's going to get close enough to the sun to where the sun is going to pull it and maybe capture it. If it goes by Pluto's orbit, however, chances are the sun won't be able to hold on to it and the planet will continue moving on. Which group 16 element has the least attraction for electrons? The exact same logic. What do groups/families in the periodic table have in common? Same number of valence electrons. Note, it says the word exact, and when it says the exact same characteristics. They have very similar characteristics. They have almost the same, but the word exact rules that out. When I showed you pictures of cesium, you'll notice it's yellow color and more liquidy, melts at lower temperatures, has more reactivity than lithium does. So even though they have very similar characteristics and properties, they're not exact. What do periods on the periodic table have in common? They have the same number of energy levels. Elements on the periodic table are ordered according to their atomic number. I did find an exception on the periodic table for mass. Beryllium and iodine, number 52 and 53. Iodine has less mass than beryllium, even though it has more protons. So it doesn't exactly follow increasing mass order. That's how it was originally, but we now order it by atomic number and not atomic mass. Which electron configuration represents a transition metal? Alright, let's look at it. Oh, so remember how I told you most places will order it in terms of increasing energy levels, and not by off-balls rule. I taught in this classroom is acceptable to write it in the same way as off-balls rule. You put the 3DS after 4S2, but most tests and places and sources would put 3DS before 4S2. Now then, the major exception here was the bottom left one. That was Serenium, number 58. It has an F block. That tells you it's a rare earth metal. I don't think I ever mentioned the name. It's not on the test. But the last two rows are called rare earth metals. At the very bottom. So we have, not to be confused with alkaline earth metals. So uranium and such are rare earth metals. They're rare because they're radioactive and don't last long. And technically all of those and the F block all have a D1. That's because even though the periodic table I gave you doesn't show it, they're technically sitting in group 3. The periodic table I use have them sitting at in between group 2 and group 3, but they're technically sitting on group 3. Which means they all get a D1 electron, and then they start filling out their F. Yes. But the fact you see a partially filled F block tells you more stronger that it is indeed a rare earth metal and not a transition metal. Alright. This is the easy version of the test. I cannot put the long, wordy problems on a Kahoot. There's also a lot of trick questions that test your ability to truly know what it is. So examples would be understanding that neon has a lower electronegativity than any non-noble gas. Noble gases have lower electronegativities than the others. That is the trend. There are exceptions. Once you get to like xenon and radon, the electrons are so far away that it's really hard for radon and xenon to actually hold on to them. Which means some atoms can come in and actually react with them. Questions where I give you like ions. Let's see if I can find some tricky questions on the test. There isn't really too many, as long as you read it carefully. It's not on the test, but I should have taught it. The last two rows of the F blocks are called rare earth metals. I use this term on the test, principal energy levels. It's the same thing as normal energy levels. It's so it's just adding the fact that there's principal and then there's sub energy levels, a sub level. You can just ignore the word principal. I also have questions that group multiple things together. Like as you go left to right, like does electronegativity decrease and atomic radius decrease, or does En decrease and atomic radius increase, and so forth like that. There's one I should really illustrate. I didn't cover too well, but let's see. What does the shape, if you were to plot atomic size, or atomic radius, versus atomic number? What would that plot look like? You should see for a group, it gets smaller. Then as you jump up to a new period, it'll jump up. And then as you move to the right, it'll get smaller. Then as you jump to the next row, it'll get bigger. Then as you move across that row, it gets smaller. As you jump up to the next row, it'll get bigger. So we see patterns like this. So this corresponds to a row. As you go across a row, it gets smaller, it decreases. And this is the start of the next row. So looking at it more like dots, you should see the dots look more like this. So as you go across a row, it gets smaller. So any questions about the test tomorrow? So study your notes. Look at the homework I passed back out. Go back over it. It'll be similar to this.